Hi guys, it's Mrs. Animal here, and right now I'm just presenting to you guys a factoring review video. We went over a bunch of methods in class: greatest common factor, difference of squares, grouping, trinomials, and a combination of the methods that I just mentioned. So I want to go through them one by one and then practice some solving at the end, so that way we're ready for our next test that's coming up and for midterms. So the first example I want to show you is with the greatest common factor. The example is 6x squared minus 18x. The first thing we want to do is we want to write out our factor list for both 6 and 18 to figure out what numbers they're both divisible by. Number 6 is divisible by 1 and 6. It's also divisible by 2 and 3 because 1 times 6 makes 6 and 2 times 3 makes 6. The factor list for 18 include 1 and 18, 2 and 9, and 3 and 6. So since we're doing the greatest common factor, I'm looking for the largest number that is in both factor lists. So that number is going to be the number 6. So I'm going to start by factoring out a 6. I also notice that both of my terms have an x, so the x is also going to come out. Now, when I write the terms that are left behind inside, I have to remember to divide. So 6 on the outside divided by the 6, that was my GCF, leaves 1. I had 2 x's and I took out 1, so 1 is remaining. I then move on to my next term, negative 18x. Negative 18 divided by 6 is negative 3. I had 1x, but I took it out to the front. So our factored form here is 6x times x minus 3. The next example we're going to do is difference of squares. When I'm looking at this example, I like this one because it really stands out. It has 2 terms, it has subtraction, and both of the numbers involved are perfect squares. So when I set this one up, I set up 2 sets of parentheses to show the binomials. I'm going to do 1 plus sign and 1 minus sign. You could also do the minus and then the plus. That's okay as well. X squared will break down into x times x, and 25 will break down into 5 times 5. So my factored form using a difference of squares pattern here will be x plus 5 times x minus 5. Then moving on to grouping. Our grouping example kind of stands out because that one has 4 terms. So I'm going to group the first 2 together, and then I'll group the last 2 together. The GCF of both 6xy minus 12y is going to be 6y. The reason why, I can go to the side and show you, the numbers that multiply to 6 are 1 times 6 and 2 times 3. The numbers that multiply to 12 are 1 times 12, 2 times 6, and 3 times 4. So the greatest number that both of these terms share in common is the number 6. When I factor the 6y out, I started with the term 6xy, I factored out the 6y, and I leave behind x. When I factor negative 12y and I factor out the 6y, negative 12 divided by 6 is negative 2. I had a y, but I took it out to the front, so it's no longer remaining. I then move to 5x minus 10. The biggest number that 5 and 10 are both divisible by is 5. So I take a 5 out to the front, and I leave behind x, and negative 10 divided by 2, divided by 5 is 2. So I leave behind x minus 2. I know that I'm doing this right by looking and seeing that my binomials are going to be the same, x minus 2 times x minus 2. I'll bring that term out to the front, and I leave behind 6y plus 5. The next example is a combination of GCF and differences of squares. When I look at this example, I notice that there are 2 terms. I notice there is subtraction, but my numbers 3 and 12 are not perfect squares. When I take out the GCF of 3, since 3 and 12 are both divisible by 3, I leave behind x squared minus 4. Now, looking inside, when I look at the piece that's remaining, the x squared minus 4, I notice that that has 2 terms. There's subtraction, and both of our terms were perfect squares. So I know I can factor that using a difference of squares pattern. The GCF of 3 carries down to the front and does not affect how I'm going to factor x squared minus 4. Since it's a difference of squares, I'm going to do opposite signs. In this example, I did the subtraction first and then the addition. I could have done the other order. X squared is made by multiplying x times x. 4 is made by multiplying 2 times 2. Since this is the difference of squares pattern, I'm looking to use the number that's the perfect square. What makes 4 a perfect square? The number 2, because 2 squared is 4. What makes x squared a perfect square? X, because x squared is x squared. And that's my final factored form. I'm then going to look at a trinomial example with you guys. So the trinomial example we will do by grouping, although guess and check is also a useful method here. We are more comfortable, I feel, with using the grouping method. So I set up doing a, c, and b at the bottom. A times c, 2 times negative 6 is negative 12. The number that goes at the bottom, negative 1, that's my b. Remember, b at the bottom. The hardest part about this example for us sometimes is actually finding the numbers that multiply to negative 12 and then add up to negative 1. In this example, the numbers I'm going to be choosing are going to be 4 and 3. I just have to make sure they end up being negative 1 when added together, so I'm going to do negative 4 plus 3, which would be negative 1. I now go ahead and I set up my grouping. So I have 2x squared and negative 6. My first term and my last term just stay the same. My middle term, however, is going to be made up using my values from the x, the negative 4x plus 3x. I now have 4 terms and I can use the method of grouping. So I'm going to look through. I'm going to take a 2x out to the front and I leave behind x minus 2. I'll then look at the next pair and I see 3x minus 6. I know they're both divisible by 3. I leave behind x minus 2. Again, I'm dividing to figure out what I leave behind. Negative 6 divided by 3, negative 2. I had a 3x, I took the 3 out, x was left behind. I then analyze and think if I'm on the right track, and I know I am because I see that binomial factor repeating, that x minus 2. I will take that out to the front, and then I leave behind 2x plus 3. I am done factoring at this point because when I look at my 2 remaining binomials, they are not a difference of squares pattern and they do not have a GCF left inside. Now I'm going to show you guys, and we're going to move on to some solving problems which are closely linked when we solve by factoring to the problems we just did. But the first step is factoring, and then we just have to do that last step of solving at the end. So in the first example, x squared minus 9, I notice here that I have 2 terms, the x squared and the 9. There's a minus sign, meaning subtraction, and both my terms are perfect squares. So I know I can factor this using a difference of squares pattern. I'm going to start by taking one addition, one subtraction, doesn't matter the order here. What makes x squared a perfect square? It's the fact that you can multiply x times x to get x squared. And what makes 9 a perfect square? The number 3, because 3 times 3 is 9. 3 squared is 9, or I can think of it as the square root of 9 is 3. I now, since I am solving here, am going to use the zero product property and set each of my factors equal to 0. So x plus 3 equals 0, and x minus 3 equals 0. And I'll solve them individually, subtracting 3 from the first piece. Leaves me with a 0 of x equals negative 3. And in the second example, I'm going to add 3 to both sides, leaving me with an answer of x equals 3. So notice the directions here. They're saying solve the following. So I have to make sure that I'm clearly denoting that my answer is x equals 3 and x equals negative 3. I'm going to box that up as my final answer. Okay. And when we're also looking at the original problem, we talk about this a lot in class, we know that this is a solving too because it's set equal to 0. Very different from our factoring problems that we did previously where they were just expressions on their own, not equations in any way. So now let's go and do the next example. I have x squared plus 6x minus 40. This is a grouping example, so I set up my x, a times c up top, which is going to be negative 40, b at the bottom, which is 6. I then find the numbers that multiply to negative 40 and add up to 6. Those are the numbers 10 and negative 4. 10 times negative 4 is negative 40. 10 minus 4, when I add them together, is going to be 6. So I want to multiply to the top and then add together to the bottom. I'm going to set up my grouping here. I have x squared and negative 40. My first term and my last term stay the same. My middle is going to be broken up into 10x minus 4x. Notice those are coming from the side of my x, those numbers that I picked that multiplied and then added the way I needed them to. And then I'm replacing the 6x with the 10x minus 4x because that is equivalent to 6x. I now set up my grouping. I will take an x out and I leave behind x plus 10. I'll take out a negative 4 and I leave behind x plus 10 again. When I'm talking about what I leave behind, remember it's division. Negative 4 divided by negative 4 leaves that 1. Negative 40 divided by negative 4 leaves the 10. I know I'm on the right track to solving because I see that binomial piece repeating. So x plus 10 times x minus 4 equals 0. Again, I now have a product of two terms, so I can use the zero product property to set equal to 0. I will solve each mini equation. In the first example, I'm going to subtract 10. And I get x equals negative 10. In the second, I'm going to add 4 to both sides. And I get x equal to 4. My two answers, clearly denoting solutions as opposed to factored form, are 4 and negative 10. Box those up and clearly show your answers. The last example, I promise guys, this is almost done, I'm going to show you is a GCF solving question. So if I look, I have two terms. They are not perfect squares, so I'm going to try to take out that GCF first. So I have a 6x coming out. 12 divided by 6 is 2. I had an x, but I took it out to the front. Negative 18 divided by 6 is going to be negative 3. I had two x's. Notice the x squared. I took one out to the front, so 1 is left behind. It's equal to 0. And right now I can go into the zero product property. 6x equals 0. And 2 minus 3x equals 0. When I solve the first one, just be careful. I'm dividing each side by 6, which leaves me with 0 divided by 6, which is 0. In the next example, I'm going to subtract 2 from both sides. I get negative 3x equals negative 2. Let's make sure I can see that negative. I'm now going to divide by negative 3. And just be careful here, guys, okay? Don't make a silly mistake at the end. I have a negative divided by a negative, which will make a positive. 2 is not divisible by 3, so I will leave it as a fraction of 2/3. So my two answers here, x equals 0 and x equals 2/3. Box that up. All right. And that's it, guys. You went through one example of each type of problem, GCF, grouping, difference of squares, and trinomials. We did a little review of solving at the end by factoring, and hopefully this is going to put you in a good spot where you'll be prepared for the test and then the midterm coming up. Thanks for watching, guys.